In my last two videos, I had explained some problems for solving Lagrange's linear partial differential equation of the form P plus Q equal to R, where Z is a function of x and y, and small letter p is dou z by dou x, and small letter q is dou z by dou y. So in this video, I'll be explaining some more problems which are listed here, in which we will be using method of multipliers also. Now consider the first question, that is solve x into y square minus z square p plus y into z square minus x square q equal to z into x square minus y square. So we can see that this is a Lagrange's equation. Therefore, write down auxiliary equation. So auxiliary equations are dx by p, that is in this case x into y square minus z square, equal to dy by y into z square minus x square, equal to dz by z into x square minus y square. So now for solving or finding solution of the first equation, it is enough to find out two equations of these auxiliary equations. So you have to find out two solutions of the form u equal to a and v equal to b of the second equation. Then final answer will be f of uv equal to 0. So our aim is to find out u equal to a and v equal to b, which are two independent solutions of the second equation. So now in this case, by the method of grouping, you cannot find out any two ratios. So we will go for the method of multipliers. So then in the method of multipliers, we will find out some multipliers L, M, N in such a way that you have to find out L, M, N in such a way that LP plus MQ plus NR equal to 0 and L dx plus M dy plus N dz equal to 0 is an exact differential. So in this case, we can see that 1 by x, 1 by y, 1 by z will satisfy these two equations. So we can choose 1 by x, 1 by y, 1 by z as a set of multipliers. Then each ratio will be equal to, so then we can write each ratio of equation number 2 is also equal to 1 by x into dx plus 1 by y into dy plus 1 by z into dz divided by 1 by x into p is x into y square minus z square plus 1 by y into z square minus x square plus 1 by z into x square minus y square. So each ratio will also be equal to this new ratio. So this is from properties of ratios and proportion. So now we can see that the value of the denominator is 0. So therefore 1 by x into dx plus 1 by y into dy plus 1 by z dz divided by 0. So therefore numerator is also equal to 0. So we can write now 1 by x into dx plus 1 by y into dy plus 1 by z into dz equal to 0. So then we can integrate this equation now. So integrating this equation, we can write this as 1 by x dx plus integral of 1 by y dy plus integral of 1 by z dz is equal to a constant c. Okay, I'll write it as log a. So therefore, integral of 1 by x dx is log x plus log y plus log z equal to log a. Simplifying, you will get it as xyz equal to a. So this is one solution of the auxiliary equation given by the second equation. Now in this case, we can find out one more set of auxiliary equation, that is x. So I'll here choose xyz as another set of multipliers. Then here we can write again each ratio is equal to, we can write each ratio is equal to, here L, Y, M, N are x, y, z. So x into dx plus y into dy plus z into dz divided by, now then x into p plus y into q plus n into r. Okay, that is z into r. That's what we have to write now. So in this case, it is x into y square minus z square plus y into z square minus x square plus z into r is z into x square minus y square. Now we can, after simplification, we can observe that the value of the denominator is 0. Therefore, we can write this as x into dx plus y dy plus z dz divided by 0. So we have chosen some multipliers, in this case x, y, z, in such a way that denominator of this ratio is 0. So therefore numerator is also equal to 0. So we can write x dx plus y dy plus z dz equal to 0. Now integrating, x square by 2 plus y square by 2 plus z square by 2 equal to a constant of integration. I will write it as b1. So you will get this by integrating. Okay. So now simplifying, you can write x square plus y square plus z square equal to 2b1. I'll take it as another constant b. So this is the second independent solution of the auxiliary equation represented by second equation. So therefore, the general solution by a theorem, general solution of the given Lagrange's equation is f of uv equal to 0. In this case, u is 1 by x, 1 by y, 1 by z, and this is plus 1 by x plus 1 by y plus 1 by z, comma, and then second equation is x square plus y square plus z square equal to 0. So this is the final equation. So therefore, final solution. So the first term you got it from the third equation. Third equation is, okay, sorry, it is xyz. Okay, third equation is xyz. So therefore, okay, this is xyz. So therefore, we can write the general solution of the given Lagrange equation in the form f of xyz, x square plus y square plus z square equal to 0. So now consider the second question. This was the second question. We have to solve the equation x square minus y square minus z square into p plus 2xyq equal to 2xz. So now here also we can observe that this is a Lagrange's equation. Therefore, auxiliary equations are dx by x square minus y square minus z square equal to dy by 2xy equal to dz by 2xz. In this case, we can see that if you are taking last two ratios, we can find out one solution. Then do that first now. So taking last two ratios, so we can write it as dy by 2xy equal to dz by 2xz. So here you can cancel 2x and 2x. So therefore you will get dy by equal to dz by z, which are variable separated, okay, which are in variable separated form. So now integrate this one. Integrating, we can write log y is equal to log z plus log a. I'll take the constant of integration as log a. So now simplifying, you can write it as y by z equal to a. So this is one solution. Okay, I'll take it as first equation, given question, second one auxiliary equation. So first solution of the auxiliary equation is equation number 3. So now we have to find out one more solution. So again, I'll take x, y, z as the multiplier in this case also. So we can write each ratio is equal to, I am taking x, y, z as the multiplier in this case. So now each ratio is equal to x into dx plus y into dy plus z into dz divided by x into x square minus y square minus z square plus y into 2xy plus z into 2xz. So now by simplifying, we can see that this is equal to x dx plus y dy plus z dz is divided by x into x square plus y square plus z square. So you won't get denominator as 0 here, but we will get the denominator in this form. So now we can observe that the derivative of the denominator, one factor in the denominator, that is x square plus y square plus z square, is 2x dx plus 2y dy plus 2z dz. So then we are getting the same term in the numerator except for constant 2. So therefore we can integrate this one. So now since each ratio of equation number 2 is equal to this one, I can write now this is equal to second ratio, or you can take it as this is equal to third ratio also. Anything is possible. So I can write therefore x dx plus y dy plus z dz by x into x square plus y square plus z square is equal to, also equal to, dy by 2xy. So now we can cancel this x and x. So then I can multiply this term by 2, so that this becomes 2 into x dx plus y dy plus z dz divided by x square plus y square plus z square is equal to dy by y. So now this is in integrable form. Okay, so we can integrate this one now. So integrating, so then integral of the left hand side is logarithm of x square plus y square plus z square. Okay, because you see what is the derivative of this term? It is 1 by x square plus y square plus z square into 2 into x dx plus 2y dy plus 2z dz. You got the same term in the numerator. Therefore, integral of the left hand side is logarithm of x square plus y square plus z square. Now, integral of dy by y is log y plus constant of integration. I'll write it as log b. So now this gives x square plus y square plus z square divided by y equal to b. Now this will be the second independent solution of the auxiliary equation given by 2, equation number 2. So therefore, general solution of the given Lagrange equation is given of the given equation is f of uv equal to 0. In this case, u is y by z, that is from third equation, and this is from fourth equation, that is x square plus y square plus z square by y equal to 0. So now in this case, we have used a different method. So here we could find out one ratio by using a method of grouping. For finding the second ratio, we found one equivalent ratio. Okay, so that one there, we got one equivalent ratio which is possible to integrate. So that is the reason we equated that one to third ratio, and we got the final answer in this form. So now we will discuss one more problem, that is solve z square minus 2yz minus y square into p plus xy plus zx into q equal to xy minus zx. So now here also we can observe that this is of the form pp plus q q is equal to r. So therefore this is a Lagrange's equation. Therefore its auxiliary equation. When you identify the given partial differential equation as a Lagrange equation, the immediate step is writing auxiliary equation. Here auxiliary equations are dx by z square minus 2yz minus y square equal to dy by xy plus zx equal to dz by xy minus zx. So in this case, we can observe that xyz is set of multipliers. So therefore choose xyz as a set of multipliers. So then we can see that each ratio is equal to x into dx plus y dy plus z dz divided by x into z square minus 2yz minus y square plus y into xy plus zx plus z into xy minus zx. Now we can observe that the denominator is 0 here. Therefore x dx plus y dy plus z dz by 0. So therefore we will get one equation like this: x dx plus y dy plus z dz equal to 0. Now integrating, we will get x square by 2 plus y square by 2 plus z square by 2 equal to a constant. I will take the constant to the right hand side so that we can write this as y square plus x square plus y square plus z square equal to another constant. So then I skipped some steps here, so you can verify that. Okay, so this is one equation of the one solution of the auxiliary equation. Now for finding the second solution, you see that in the last two ratios, okay, in the auxiliary equation, you check the last two ratios. So here we can cross multiply this one and you can see what is possible here. Okay. So we can write this as, taking last two ratios, we can write dy by xy plus zx equal to dz by xy minus zx. So now you see x is a common factor. So you can cancel x from everywhere, so that we can write it as dy by y plus z equal to dz by y minus z. See now, it contains two different differential coefficients dy and dz, and it is free from the variable x also. So therefore the solution is possible here. So I will cross multiply. So we can write it as y dy okay, by cross multiplying y dy minus z dy equal to y dz plus z dz. So then I'm comparing everything now. So we can write y dy minus z dy minus y dz minus z dz equal to 0. Now then, this is possible to integrate y dy. We can integrate z dz also. Now then, we can combine these two terms so that we can write it as y dy minus d of zy or yz minus z dz equal to 0. So now we can integrate this equation. So integrating y square by 2 minus zy minus z square by 2 equal to constant of integration b. Or I can multiply throughout this equation by the constant 2 and we can write this as y square minus 2 yz minus z square equal to constant b, or we can write it in this way. So this is the second independent solution of the auxiliary equation. So now we can write down by the theorem, by using the theorem we can write down solution of the given equation. So solution of the given equation is f of uv equal to 0 form. So in this case u is x square plus y square plus z square, and second term is y square minus 2yz minus z square. So therefore this function will be equal to 0. So then there are different, to conclude, there are the method for finding Lagrange equation is writing auxiliary equation and find out two independent solution of the auxiliary equation. Now for finding two equivalent two independent solution, there are different methods. Sometimes by grouping some ratios you will get the answer directly, or sometimes you have to go for the method of multipliers, or sometimes you have to find out equivalent ratios and you should be equated that equivalent ratio with the original ratio in our auxiliary equation, and somehow you have to find out what you have to do is you have to find out two independent solution of the auxiliary equation. At the end, by using the theorem, using a theorem, write down solution of the Lagrange equation in the form f of uv equal to 0.